I'm Anil Kumar. In this particular video, we'll try to understand how to write equation of any polynomial function from the given roots. When the roots are given to us, we actually know the solution of the function, and the idea is to do the reverse calculation and find the function itself. So I have three examples. First, write quadratic equation for a function with roots at x equals to 2 and minus 3. The second one is write cubic equation for a function with roots at x equals to minus 1 and x equals to 2. And the third one here is write cubic function with y-intercept of 4, zeros of order 2 at 1, and linear zeros at plus minus 2. As you will notice in these three examples, we are using different terms. We are using roots. We are using the term as zeros. Sometimes we can also use x-intercepts. All the three terms are kind of related, and their relation could be shown something like this. Let's say this is our coordinate plane. In that case, let me sketch a function here, just a general function. Let's say we sketch a function like this. The points where the graph of the function crosses x-axis, these points are called x-intercepts. So wherever the graph crosses the x-axis, those points are called x-intercepts. Now, if we are working with any equation, let us say of the form f of x equals to something, then f of x equals to 0. For that particular function, these x-intercepts are solutions, right? So we call them roots. So roots are solutions of equation, where the equation is f of x equals to 0. That is kind of very important to understand. Now the term 0 here has added information. Zeros, you can say, are x-intercepts in a way, with additional information. And what is that? Additional information is behavior of the graph or the function at the x-intercept. You will see that in this particular case, let's say point, I could say this is at minus 4, for example. So at minus 4, we'll say it goes straight. So this behavior is kind of linear. Here it turns. So it is of even nature, or you could say quadratic, right? So here the 0 has order of 2 or 4 or something like this. So whenever it turns, it is even degree. At that point, is it okay? Here again it is linear. So I hope this concept is clear. So it's very important to understand the three terms which we normally use. Okay, so let's get back to the solution of finding equation now. So what we understand from this discussion is that if I say write quadratic equation for a function with roots at x equals to 2 and minus 3, it means that if I write a function like x minus a times x minus b equals to 0, then a and b should be values such that for x equals to 2 and x equals to minus 3, we get a 0. You get an idea, right? So we say a and b should be values so that for x equals to 2, we have a 0. That means for x equals to 2, x minus a equals to 0. If x is 2, I could write 2 here. So I get 2 minus a equals to 0. Or we can say from here that a equals to 2. So it results into a factor in this particular equation, which is of the form x minus 2. Do you see that? Similarly, for minus 3, the other factor will be 0 only if b is plus 3. So we get the other factor, which is x plus 3. Equating that to 0 gives us an equation in factored form. At times, you may be required to write this equation in standard form. Okay, but here we're just understanding the concept and we'll leave it here. We'll write the equation in factored form. So we are writing equations in factored form. So I hope that is absolutely clear. So now, if you look at the roots and the equation, you can directly correlate. So you could write in general that this value, let us say x1, that value x2, if those two values are given to us, then we could write an equation as x minus x1 times x minus x2 equals to 0. Perfect. And we get our answer. Is it okay? Right? Now using this as the concept, let us answer rest of the questions. You can now pause the video, answer these two questions, and then look into my suggestions. So the question here now is, write cubic equation for a function with roots at x equals to minus 1 and x equals to 2. Now if I use this concept, then the equation is x minus of minus 1 is plus 1 times x minus 2 equals to 0. But this is not a cubic equation, right? This is a quadratic equation. So if you have to write a cubic equation, what should you do? Well, one of these factors should be of order 2, right? So you could write like this, or you could even write x plus 1 times x minus 2 square equals to 0. Both are correct solutions. Do you get an idea, right? Now, whenever we are only given roots, whatever equations we are doing, these are not the only equations. We actually get a family of equations. So I could have written this solution as any number k times x plus 1 times x minus 2 whole square equals to 0. Because all the equations will satisfy the given condition. 0 times anything is 0. You get an idea, right? So we say that is the family of polynomials. Okay, so this is another concept which should be clear. Now the third example, what I have done here is, let's read it. Write cubic function with y-intercept at 4, zeros of order 2 at 1, and linear zeros at plus minus 2. Now since I have given a point on the curve, we are now asking for a specific solution, right? So in this case, we'll write the equation, right, which will satisfy that condition. So this is specific curve. Do you understand? So that is how it is different from the other examples. And I hope with this, you get the whole concept. Now let's do the third question, which is, write cubic function with y-intercept of 4, zeros of order 2 at 1, and linear zeros at plus minus 2. So what we're given here is, we say y-intercept of 4. It really means that there's a point P where the x value is 0 and y value is 4. So the curve of the function goes through this point. One thing, correct? Then we have zeros. So we have a 0 of order 2 at 1. It really means that there is a factor. At 1 it is 0, so x minus 1. Order 2 means power is 2. The other one is linear zeros. At plus minus 2, right? That means there are two different zeros. One is at x minus 2. The other one is at x plus 2. You get an idea, right? So this is the information which is given to us in the given question. Now, combining all that, we can write our function. So we say now the function should be some factor k times x minus 1 whole square times x minus 2 times x plus 2 should be equal to 0. Okay. Now in this equation, if I substitute x equals to 1, this first factor will be 0. X equals to 2, second factor will be 0. X equals to minus 2, the third factor will be 0. How do I find k? To find k, we have the y-intercept, the point 0, 4. That should be satisfied. So I'll replace x with 0, y with 4 to get the particular equation, right? So what we will do now, we say it is not 0, but we have a function f of x which is equals to all this. And it should be 0, for 0, the y value should be 4. You get an idea, right? So the y value should be 4. So we replace x with 0, write 4 for f of x. So we get 4 equals to k times 0 minus 1 whole square, 0 minus 2 times 0 plus 2. And that gives us 4 is equals to k times, that is plus 1. This is minus 2 times plus 2. Or 4 equals to 2 times 2, 4, minus 4k. And that gives you the value of k as minus 1. And therefore, we get our function with specific value of k, which is minus 1. So we can write down our equation as f of x equals to minus x minus 1 whole square times, you can combine these two, right? If you multiply, you get x squared minus 4. Okay, so that becomes the solution, or I should say the equation which will satisfy the given conditions. Do you get it? So that becomes our solution in the given scenario. So now let's look back into all these questions once again. Now when we say write quadratic equation, so that gives us 0, I should have written here quadratic equation as, let me rewrite, as y equals to x minus 2 times x plus 3. In this case, my equation should have been y equals to x plus 1 times x minus 2 whole square, or y equals to x plus 1 whole square times x minus 2, or we could write any factor here. Okay, so that is what it means. So writing equation will be relating independent variable with the dependent variable as shown here. Is it clear, right? So that is how you provide an equation for the given roots, x-intercepts or zeros as we have discussed. I'll provide you with few links which will help you to also write equation for polynomials if the roots are complex roots or radical roots. I hope that helps. Feel free to write your suggestions and comments. If you like and subscribe my videos, that'll be great. Thank you and all the best.